So today we're going to be doing our notes for section 7.2, and it's calculating probabilities of events using two-way tables. And this is actually a really cool way of calculating probabilities. We're going to be organizing our data into a table, and it really helps you like visually understand what you're doing. So with that, let's take a look at these notes that we have here. So it's just a problem, and we're going to organize the data in the problem in the table. You can see it's already done. So should Mathville get a new shopping center? That's the question that the problem asks. And you can see there that it says a random sample of 515 voters was taken. Each person was asked whether the town should grant a builder's request for a permit to build a new shopping center. Part of the results are in the table below. So then you can see here, example 1, complete the following two-way frequency table. Well, let's kind of let me review a few things here. So 1, it says you have a random sample of 515 voters. Well, that 515, right, that we have right here, you'll notice that that number is what sits in this location right here. Okay, it's the total of totals, basically. You can see that it's in the total column, right? And it's also in the total row. Okay, the far right column is always totals for the rows, and the bottom row is always the total for the columns. Okay. So with that said, notice, let's just continue to read through this. So then the next sentence, right, it says each person was asked, right, and you can see from the chart that we have male and female people. So I'll just put on here, so each person, right, so we're talking here male, female. And then grant a builder's request to build for a permit to build, right? Okay, so you can see here, right, the two ways. One is based on the person's gender, male, female, and then the second is based on the answer. The answer can be a yes, right? We can see from the table it could be a no. Okay, and it can be a no answer. You guys see that from the table? Okay, so I already said that when we come to these totals here, that the rows, right, add up to it. Meaning that if I take 19 plus whatever this is here, plus that 6, it should equal the 300, right? And then this one's missing quite a bit. This plus this, right, equals 215. So, and also the columns, right, should add up to whatever number is down here. So like for this column here, you can see it's 6 plus whatever is here plus the 12. I'm sorry, equals 12. All right, so let's complete this table. So we're going to use those facts. Let's come over here. So the first thing that I'm going to do is I'm going to figure out, I'll label this as 1, and I'm going to figure out this row here, because I only have one missing box. And so what I know in that row, there we are. So I'll put a 1 here, just so we can find my work if you need it. I know that 119 yeses plus X is the number of no's plus 6 has to be equal to 300. So 119 plus 6, right, if I add like terms on the same side, is 125. Has to equal to that 300. So you can see here x is, and that's going to be 175. Are we okay with that? So even the total row has to add up. So this will be the next one that would be nice. I'll find this box right here. So the total roll has to add up to the great total. And so we have here 2, and that will be, I'll use y to represent the yes for the total roll, plus the 230 plus the 12 has to equal to 515. So 230 and 12, that's 242, equals that 515. Subtract the 242 from both sides. You can see here you get 273. How are we doing? At this point, let's just put a little note here at the right underneath this. I'll just say, notice, okay, I am picking rows or columns slash columns that have only one unknown. Okay, are you guys okay with that? Yeah? Okay, let's find the remaining missing. I'm going to come over here now. And I'm going to find the missing box here in this column. So this is going to be my equation number 3. And notice that here, right, it's going to be 119 plus this unknown here, I'll call it A, has to be equal to the 273. So 119 plus A has to be equal to 273. So if I subtract the 119 from both sides, I get 154. Okay, might as well just do the next column here for this one. And that one is going to be 175 plus B is equal to 230. When I subtract the 175 from both sides, notice you get 55. Then finally get the last missing box. There's a couple ways we could have done. I could find the column if I wanted here, or the row, but since I'm doing columns, I might as well continue doing columns here. So 5, and notice that this is 6 plus, I'll use C to represent that, equals 12. Subtracting 6 from both sides, or yeah, you get 6. Okay, so is filling in the table going to be difficult? Yeah, it's not going to be bad at all. Okay, so let's take a look at the following 3 examples. It says, use the two-way frequency table to answer the following questions. So I'm going to come down here. The first question is, what is the empirical probability of choosing someone who supports building the shopping center? So notice a couple of things here. Empirical probability means it's going to be based on the actual numbers that we have, right? Theoretical is based on the theory of what the numbers should be, right? So I will come over here. It says, what's the empirical probability of choosing someone who supports the building? Right, the shopping center, that's what I'm looking for. So I'm going to come down here. And I'm going to write, I'll just go ahead and write over here, probability of, and then I'm going to write someone supports building, right? Remember, empirical is number desired over number observed. You could still use favorable and total. They like to try and distinguish the vocabulary because of empirical being actual data, right? Um, but you could still think of it in terms of favored and total. You just have to think in terms of then the data. So how many people support building? Okay, is it based on gender? Nope. So I'm not going to look at the number for, I'm going to look for supporting the building, right? That'd be a yes, right? But I'm not going to look just at the male or just at the female, right? Since it's just people, we're looking for how many people total say, right? Now you're all like, well, that's total, right? But it's the total number of yeses. It's not the total number of people, right? So this is the desired outcome. It's that 273. Over, and then how many people total are there in this survey? Yeah, it's the 515 that's right here. That's the total of totals, 515. Okay, and then if I get a calculator out here, right, and I do 273 divided by 515 is equal to, and we usually do 3 decimal places. It'll be approximately, I'm going to round, 0.530. Okay, but you guys know that's how many percent? 53%, right? I think we think in percents better, but they like to write their answers in decimal. Okay, so 53%, right, would be of the people would support building the shopping center. Example 3. If a person was picking, if I were to pick a person at random from among the females, do you think that she would support building the new shopping center? Why or why not? Oh, yeah, I'm going to start showing this is some advanced way of writing it, okay? So notice here that we're picking a person among the females. So do I care about the males at this point? So notice here, I'm going to write this a little bit higher because I'm going to write some words underneath. Probability, right, that I'm going to say here supports the building. And then I'm going to use this vertical line here. And that line basically means given that we know that we're asking a female. We technically had a given in the last one, but it was the entire population, right? And so we don't have to say that. So I'll just say here, this line means given. Since that is telling, now in a couple lessons, we're gonna focus, right, on just doing these kind of conditional probabilities, okay? but not for a couple of days. But they do bring this up because they want you to be thinking about this. And so notice I'm not looking at the whole chart anymore. This one is saying focus only on the females, and so I'm only going to be looking at this line. So I'm going to highlight this line here, right, that describes females. I'm going to highlight it in orange, and that's all we're going to look at because we said if we pick a person at random from the females. Does that make sense? Yeah? Okay. So from the females, right? So we're going to still do number desired over number observed. So how many of the females, right, have the desired response, right, which is they support the building? Well, looking only at the orange row up here, right, how many of the females would support building the shopping center? Good, it is. It's the 154, right? That's right here. Okay, and then what's the total? Ah, good job. It's going to be 215 because remember we're only looking at this row, right? We're not looking at the entire population because we know we're pulling it from the females, right? Remember that right here, from among the females. And so therefore we're going to say 215 down here. So when I put that on my calculator, 154 divided by 215 gives me 0.716. Oh, what's the percent that represents, you guys? Good, 71.6%. So do you think that if the random woman that I asked would support building the new shopping center? Yeah, I would say if I were to pick, right, a random person from the females, I would expect her to support building the shopping center, right, as the empirical probability is 71%, right? So I'll write that here. So they weren't necessarily expecting us to calculate the probability at this point, but I figure you guys can understand this. So if I am to pick a random person from the females, I would expect her to support building the shopping center as there is an empirical probability of 71.6%. Right, of saying yes. Okay, are we good with that one? Okay, look at example 4. Now it says, if I were to pick a random person from the males, from among the males, oops, I wanted that to be green. Do you think that they would support building a shopping center? Why or why not? So this time I'm going to do the probability, right, that they support building, right? Given, right, there's that line, that they're male. So I am going to do my number desired, right, over the number observed. So this time, right, since I'm looking just at the males, okay, I am going to look just at this row here. So just from that row, how many of the males would say yes? Yeah, it's the 119 right there. Divided by, and then what's my number observed? Yeah, remember we're just limited to that view now, just looking only at that row, so it's 300. And then we can stick that on our calculator. 119 divided by 300 is 0.397, 0.397. Right, and we know that as a percent, that's 39.7 then of men would say yes. So do we think that the men would want to build a new shopping center if we came up and asked a random male? And the answer would be no, right? So I'll write my complete sentence here, right? So if I were to pick a random person from the males, I would expect them to not support building the shopping center. As there is an empirical probability of 39.7%. Okay. Any questions? Get the idea? How to build. The big thing is on this lesson is, can you build a two-way table given information? And often they don't give you a filled-in table. It's going to be in the words in the paragraph right before the table. So you're going to have to fill in, know where to put things. And then just looking at the table and being able to do simple calculations like this. That's my expectation today. So with that, we'll end the lesson.